Another thing you'll be asked to do is to have a look at hybrid functions. Now, hybrid functions look like this. So we've got f of x equals will be 2 or 3 like smaller functions, and they'll let you specify the domain like we do here. So what we're saying is that this function, f of x, is equal to x squared, where x is less than 1, and also negative x, where x is greater than or equal to 1. So I've made a mistake here. I'm going to just put a line through these and change this to x is less than 1 and x is greater than or equal to 1. So that's the notation. I forgot to put the x's in here. Anyhow, so what they'll ask you to do, they'll get you to evaluate f of x at a couple of points which are pertinent to the information that you've been given up top. So at x equals negative 2, which one of these two functions are we going to use? Well, we'll use the one that says negative 2. Will that be where x is less than 1 or x is greater than or equal to 1? It's going to be this one, the top one, because it's negative 2 is less than 1. So that's what we're going to substitute in. So we're going to have, so we'll use x squared. So we'll have negative 2 squared, and that ends up at 4. For x equals 1, once again we choose the function that we'll use. And we see that for 1 we've got to use where it's greater than or equal to 1, so we're going to use negative x. So we're going to have 1. So negative x becomes negative 1, so it becomes negative 1. At x equals 2, same deal, it's greater than 1, so we're going to put in negative x. So we're going to have negative 2, so it ends up being negative 2. So from there, what you'll be asked to do is to sketch it. Now these get a little bit tricky to sketch, but with practice you get there. So we know that between, at any x value less than 1, we're going to have x squared, and at any x value greater than or equal to 1, we're going to have negative x. So this idea of 1 is a key point. So at 1, we'll have 2 points. We will have, for x squared, at x equals 1, we're going to have y equals 1. And for negative x, for x equals 1, we're going to have y equals negative 1. So for the parabola, we're going to have x squared, so it's going to come down, touch the origin like x squared does, and then stop there. Now because of the less than, it's going to have a circle. It's got an open boundary. Then at 1, we're going to have a closed circle, and we're going to go off that way. So this first part is x squared, and this second part is negative x. And then we identify the key points that we may have. So that means any intercepts and also our endpoints. So here we've got 1 and negative 1, and just 1 and 1. So that's 1 and 1, and then over here we've got 1 and negative 1. Now, something interesting happens at this value of 1. We say the function is not continuous over here because there's a break in the function. So, because we've got the open circle and then a closed circle, we say that it's not continuous at that point there. But that's something there's something else you'll ask me to define, whether the function is continuous at this point or if it's not continuous at any point along its journey.